Welcome to this tutorial, where we are going to be setting up our development environment for the Binance Smart Chain using Hardhat. Hardhat is a development environment for networks compatible with the Ethereum virtual machine and therefore serves to develop decentralized applications on networks like Ethereum, Polygon, Avalanche, and of course the Binance Smart Chain. Hardhat provides us with tools for compiling and deploying contracts, a local test network called Hardhat Network, an integrated debugger that makes it easy to find and fix errors in your contracts and dApps, a complete set of tools to test contracts and dApps. To develop in Hardhat, we first need to install Node.js and the Node Package Manager npm on nodejs.org/en/download. Link in the description. We can find Node installer files for each operating system and architecture. If you are on Windows or Mac, you can easily install Node and the Node Package Manager by downloading the corresponding file, running it, and following the instructions. On Linux, we will do it in the terminal by running the commands apt update apt get install node apt get install npm. In our development environment, we also use Visual Studio Code, which you can install on the page code.visualstudio.com/download, link in description, by downloading and running the file corresponding to your operating system. And we are ready to develop in Hardhat. We are going to create a folder with a name we want to give the project and drag it to VS Code. We open a terminal and run npm init --. Yes, this initializes a node project, creating the file package.json. With the initialized node project, we can install Hardhat with the following command. We will also install the Hardhat toolkit. With this dependency, we will have access to additional Hardhat tools. To use our local Hardhat installation, we must do it through the Node Package Runner or NPX, which allows running node packages without having to install them. NPX is automatically installed with Node, so we should already have it available. To create a new Hardhat project, we will run npx hardhat and use the default values. And use JavaScript. The root of the project will be the same as the one the terminal points, and we will create a git ignore. In the VS Code Explorer, we see how the Hardhat config file has been created. This file defines the configuration and parameters for Hardhat and its plugins to work properly. Here, the networks that the project will work with will be defined, the keys and accounts that will sign the transactions. The Hardhat plugins are imported and configured, such as the Waffle testing framework. Specific tasks can also be written to run with the Hardhat command called tasks, as well as other uses for this configuration file. The following folders have also been created. Contracts, where the Solidity contracts that we will deploy to the network will be located. Scripts, where we would execute the necessary commands for development, such as deployment commands, interacting with the blockchain, creating new wallets, and so on. And the folder tests, where we will write code focused on testing the functionality of our contracts through frameworks like the aforementioned Waffle. If we go to the contracts folder, we see how Hardhat has created the log sol file. This file defines a smart contract with specific functionality that will allow us to explore part of Hardhat's potential. This contract is designed to freeze any funds sent during deployment until a future time, after which they can be withdrawn by the same account that originally deployed the contract and sent the funds. It starts by defining the Solidity version to work with, and then defines the lock contract. Inside the contract, the unlock time variable will be defined as a public integer. This is where the time from which funds can start to unfreeze will be stored. And by being a public variable, any other contract can read this information. The address variable will store the account that deploys the contract and sends the funds, which will be the same account that can later withdraw them. It is defined as payable since it must send and receive funds. A withdrawal event is defined. Events in Solidity serve for contracts to emit information for external agents that may need it. In this case, it reports that a certain amount has been withdrawn at a certain time. The contracts constructor is defined, which is a special function in Solidity that only executes once when deploying the contract. The constructor of this contract receives the parameter of when to unfreeze the funds. It is defined as payable since the contract will receive the funds to be frozen and later must send them. Inside the constructor, the explicit requirement is established that the network time must be earlier to the unlock time in order to deploy the contract, otherwise it will show an error message. Then in the constructor, the unlock time and owner variables are updated. Finally, the contract defines the public withdraw function, where two requirements are declared. The first is that the unfreeze time has been met, and the second, that whoever accesses the function is the same address that deployed the contract. If these requirements are met, the withdrawal event will be emitted with the contract's back network time, and the frozen funds will be transferred to the contract owner's address. To deploy this contract on the Binance network, we are going to modify our hardhat.config.js file. We will define the mnemonic constant that will be taken from the secrets JSON file. We will create this file with the touch secret JSON command, and inside it we will create this object with the mnemonic parameter, and we will place our secret phrase that we can obtain in MetaMask. Remember, this wallet must have funds for the operation. For now, we can request test BNB by placing our wallet address at testnet.bnbchain.org/faucet-smart. Link in the description. We modify the Solidity 2 version to 0.8.9. We are going to define different networks in the following way. Let's temporarily set the default network to testnet as follows. And now we create the network's parameter, and inside it, we define the localhost network to the localhost address 127.0.0.1 in the port 8545. And we define the testnet network. To use the Binance testnet, we will create a Quicknode RPC. We log into quicknode.com and choose to create an endpoint and select Binance Smart Chain testnet. And after creating the endpoint, we copy it and paste it into the URL parameter. We place the chain identity 97 as shown on screen, the gas price, and in the accounts parameter, we place our mnemonic variable. We will also create this pass parameter with the pass as shown on screen, and this Mocha parameter with the value of 20 seconds timeout. Mocha is one of the testing frameworks we'll be using in the Hardhat environment. With these configurations ready, we can run npx hardhat compile. To compile our contract, if everything's correct, we are going to be using our deploy.js file located in the scripts folder to deploy the contract. Let's inspect this file. We see that a constant is created that requires the Hardhat module to access deployment utilities. The main function is created where two numeric constants are declared, one for the current time in seconds and one with a time 60 seconds after the current one. A constant locked amount is declared with the amount to freeze of 0.001 ETH. The contract is deployed using the deploy contracts function available for the HRE constant. This function receives the name of the contract to deploy as it appears in the JSON file inside the artifacts contracts folder. And we must send the arguments received by the contracts constructor. In our case, the unfreeze time, and we will also send funds in the transaction, placing this value parameter, which will carry the amount in ethers that we have declared. We use the wait for deployment function available for the contract to wait for the transaction to complete. We log the information corresponding to the functionality of our contract and the address of our deployed contract in this way. Finally, the main function is called with error handling included as follows. Now let's deploy the contract by running npx hardhat run scripts /deploy.js. We get the message that 0.001 ETH has been frozen, which in our case will represent testnet BNB with the unfreeze time and the contract address. If we want to verify the operation, we can paste the address of the deployed contract in testnet.bscscan.com, and we see how the contract has received 0.001 BNB from our account. Finally, today we are going to create our own script to access the withdraw function of our contract. For this, in the scripts folder, we create a withdraw.js file. We declare the constant HRE to import the Hardhat module, and in our main function, we declare a constant with the address of the contract we have deployed. We are going to use the read_effects function, with which we can access all the functions of our contract that are specified in the log. JSON file created in the artifacts folder. When compiling the contract, we get the signer accounts as follows. Remember that here will be the account defined in the Hardhat config file, obtained from the secret JSON file. Now we create an instance of the contract in the following way, using the address ABI and the account that will sign the transactions. And with this instance of the contract, we can create the transaction by accessing the withdraw function of our contract. We wait for the transaction to finalize in the following way and display the message that the withdrawal was made. Finally, we call the main function and include the proper error handling. If we run npx hardhat run script /withdraw, we can see the message on the screen once the transaction is complete. We can verify also that the funds are gone out of the contract and into our account. In the next video, we will be using Hardhat test functions to prepare our environment for developing on the Binance Smart Chain and on any other blockchain compatible with the Ethereum virtual machine. Don't forget to subscribe, like, and comment